Hey, and welcome back to Code Reviews. So in this episode, we are going to Docker-ize our Spring Boot application. So we're going to run it on Docker versus running it locally. As a quick overview of where we've gone, first we built a GET API with Spring Boot that ran locally on HTTP. So we got it running, and you could access it going to HTTP localhost 5001. The next step we did was run that API on HTTPS locally. HTTP wasn't really useful for us. You need to run things on HTTPS. So we set up Spring to do that so we could access it locally from there. Today, we're going to Docker-ize our application. Now, before I get to the code, I'm going to run through these slides because Docker is as much of a conceptual thing as a technology thing. So why am I going through this added step of using Docker? You may have noticed if you've followed along so far that there's a problem with my code. And the problem is that my code may not work for you out of the box. So you may see me run it just fine and everything's good, but when you clone the repo and you try and run the code, it doesn't work. So two of the main reasons this may be the case is the operating system. I'm using Mac OS, you might not be. Certainly if you're Windows, that's an issue. If you're on some type of Linux distribution, it could still work, but it may not, simply because I'm running it on a Mac and you aren't. The other thing that comes up is the Java version. So I'm using Corretto 17. We've talked about that in other videos. You may not have that installed, and that's causing issues because you can't run a jar that's compiled against an older version, or you can't compile my code at all because you don't have the code we're specifying in the configuration. So this is a pretty common problem, which is how do I guarantee that my code will run the same for you on your computer as it does for me on mine? Because if the code doesn't work for you, what good is it? One solution to this is Docker. Instead of running raw code, we create self-contained containers that can be run on Docker. The emphasis there is on self-contained. What does this solve? The operating system. The container is going to bring its own operating system. It's not going to run Mac OS. It's not going to run Windows. It's going to run whatever it comes with. And the code is going to be tested on the software, on the operating system that it's given. So when you have this container I've built it on, it brings its own operating system, and the code has already been tested and is ready to run on that. The other thing it does is the Java version. So I can pre-install the version of Java that I want you to use. So I'll build this container. It'll have an operating system. It'll have a Java. It'll have my code with all the dependencies that it needs. And once you build that container, either from source, or you can pull the container pre-built, you can run the code, and we're then guaranteed to run the exact same thing. So this is a way to really improve usability of the code and to ensure that what I'm coding for you will work and you can use it in a useful way. And you're not stuck just running it locally. That's a high level of what we're doing and why. So we'll run through a little demo of running what we have now locally versus Docker to kind of show you what I mean. So we can build and run, we'll start the code, we'll build and run the code locally. This is what we've been doing before. It's going to build the jar, do all the checks, and it's going to start the jar. So we can check that it's working by going to, localhost. Great, it works. What I want to call out is you can run a command. So PS is a command that shows you running processes on your computer. And you can see when you run PS that locally, you can see that the Java Spring Boot service is running in the background. When I kill this and I run PS again, it's gone. So you can kind of see this relationship between, okay, I'm running this locally and I see it in the background running locally. And it works here, and now it doesn't work here. So now I'm going to build and run the application on Docker as a container. I'll stop my Docker to show you just some of the error handling. Docker. So this is its own special build script. It's going to fail because it says the Docker daemon isn't running. So I have installed Docker here, and so I'm going to get it started in the background. And once you've downloaded Docker, you get the Docker engine running, you should be able to run this code. So I'll rebuild, and I will run it locally. What you will see is a few extra steps as it builds the container, and then it runs the container. So we see the same printout from Spring. We're seeing the logs on the container. We can check and see, does the app work? It works. But when we look at processes, you can't actually see that same Java code. You can see that Docker's running, but the actual Java Spring Boot code that we saw isn't there. So if it's not running here, where is it running? So when you have Docker, there's a command, Docker-ps, which shows Docker processes. And you can see that the full stack auth repo, Spring Backend, is running, and it's been running for 34 seconds. So what you're seeing is my local isn't running the application. I've built a container with everything that I need. Docker is running that container on Docker, and so it's completely isolated, it's self-contained, it's there. So you can just download this image and run it locally from Docker, and it'll work the same way. That's pretty cool. And you can also actually log in. So you can do present working directory on your local, and this is where I keep things on my local directory. But I've given you another command, which is login, Docker login. And when you log in, you're actually in the Docker image. So like I told you, it's an operating system the same as Mac OS is, and you can basically do everything you can. It's a different type of shell. It's an ASH shell, ASH, for Alpine instead of Bash. But effectively, you are in a virtual server, this container, and you can do whatever you want here, and it's completely isolated from your front end, which is really cool. And it makes running things much better. And also, when we start to add the database, that's also good, because you don't really want a database running locally. You can bring it as a container. And we'll get to that in later episodes. But that is a quick review of the Docker. So I hope that was useful. Let's go through the code. So we're at the regular repo. We'll go to the O2 branch, and we'll look at the code. So what did we have to do to Dockerize our container? So the first code we'll look at, I simplified the make files. So there's a top level make. It's much simpler. It's just 2 commands. It seemed dumb to have so many. So at the top level, I kind of specified that. And now there's one. You can still do things locally, build and run local, but you can also build and run with Docker. So if you have Docker, use Docker. If you don't have Docker, you don't want to get Docker, you can't get Docker, you can still try and do it locally. I updated the README. It's always good to make sure that your README is up to date. All right. So we can start. We'll come back to the Docker file. The make file, again, I just added Docker commands, so you can still build and run things locally. This is the make file specific to the Spring repo, shortcut commands. All right, we'll start here with the env script. So I have added a few things. We've always had kind of a Java check, and I have an SSL file check. This is to help you make sure that you've run the SSL script that you need when you're generating, when you want to run an HTTPS. This will basically tell you, hey, this isn't going to work because you're missing this script. It'll give you some information on how to do it. I've also added a required program check. So I've added a required program check because if you are going to use Docker, you need to have Docker installed. So in the run as Docker container script, which is run the Spring Boot jar locally as a Docker container, before you get there, I actually have a required program check. You can see it in action. I'll change this to something I don't have. We can run bin docker startup scripts, run as a Docker container. and it says Docker-ize could not be found. It's checking to see, does this Docker-ize return anything? And it says you'll need to install Docker, and it gives you the website. So you can go here and download it for whatever you have. So it's just a way to be helpful. Required program check. And these are shared functions, which is why we put them in the .env. So the SSL file check happens in everything that we run. So we check for the file, whether we run it locally or through Docker. And then the required program check is something that we would obviously reuse. So we write it here where it's imported across different scripts, and you can check for programs. It's pretty useful. So those were the changes that we made to the env just to make the repo more useful, try and get you up and running more easily without having to ask kind of questions. So then we have the build and extract jar. So what is the build and extract jar? Let's check the help and see what it says. It's a build script for usage with Docker deployments. Specifically, this build leverages the Spring Boot layer information. You can learn more about this layer information in the documents that I've attached. But effectually, to extract the jar into layers based on how likely they are to change. This will make the Docker image layers even more efficient. So basically, when Docker is creating its container, you're just copying all of the code, or in this case, the jar, over to create the image. But that can be inefficient because, as you'll see in this, they have a really good image here. In a Spring Boot application, there are things that change frequently, and there are things that change very infrequently. Now, when you build an Uber jar with Spring, it's going to include absolutely everything. The things that don't change and the things that have changed. When you use the layers, you're breaking it into 4 different layers, ranked from infrequently changing to frequently changing. Now, if 3 of those layers don't actually change, Docker can cache them, and you don't need to recopy them because there's no reason to. You should only recopy things that have changed, and this keeps builds fast and smooth. So, as part of this build script, it does that, okay? So, it says running the build script location to build the jar locally. So we still build the jar, the same as we were before. But then it goes into the target directory, creates a new directory that's called extracted. See that over here. And it has these 4 different layers. It runs this jar mode layer tools jar. It extracts the different layers, and it puts them into this class. So you build the jar, and then you extract it into different layers with differing types of changes. Now, the way you use this is in your Dockerfile. So we've looked at this, and now we'll go back to the Dockerfile. The Dockerfile is how you write commands to actually build and configure your operating system. So if you look into the Dockerfile, you have from OpenJDK 17 Alpine. So this is the operating system we want to use. It has, actually I don't think I want to use this one. I want to use the Corretto one. Anyway, I'll change this to Corretto. All right. So now we have the Alpine OS with Amazon Corretto 17. We're creating a user and a group so that we don't do everything as root. I'm just creating a variable for where all the extracted layers are. And then we're literally copying from my local location to the root directory location in the container these 4 things. And then we're going to start. Now this is the fancy way. There is a brute force way, which is basically you just copy the jar that you create directly onto the container, and then you just call Java jar, and you call this. This will work, but it's less efficient. You're always going to be copying a much bigger file, especially as your jar grows, than what you really need to. So we just have this Dockerfile, which pulls in an OS, creates a user, creates a variable, and then copies the source code from our local to the container, and it runs it. Pretty simple, pretty straightforward. You can do a lot of complicated things with it, but we don't really need to, fortunately. So that's the Dockerfile. So build and run Docker, it's just a composite script. So it just pairs together the build and the run. Nothing too crazy there. Docker login, we'll go back to that. So you have Docker run as a container. All right, so run the Spring Boot jar locally as a Docker container. The script assumes you've already built the jar for use with Docker using the build and extract jar. So it does the required program check and makes sure you have Docker. It checks for the SSL file that it needs to run on HTTPS. And then it runs Docker compose build and Docker compose up. And then it removes any orphans just to keep your memory clean. So you have this Docker compose file. And what Docker compose does is it orchestrates many different Docker files. Right now we only have one thing going, but in the future we're going to have a database and we're going to have a front end and we're going to have many different containers working with each other for a full stack web application. Because of that, you need a way to orchestrate everything. We have different apps in under services, and for now we just have the one. It's the Docker default image. The build is just build from where you are. We link ports. So this is actually a mapping. So it's a local port to a Docker port. So the Docker, if Docker is running on 5000, we would hit it with 5001 locally, and that would map to 5000. So it's an example of this. If you go to local properties, run this. So we will build and run. So we're going to run this on 5000, and what you'll see is you can control your local ports and how they are mapped to the Docker ports that are open. It's been recreated. It's going. Let's see, is it running on? So it's running on 5000. If we try to access that with 5000, it will not work. But if we try and access it on 5001, it does work. And that is simply because in our Docker compose, we are mapping here. This is just something you can do. I can't give you a good specific reason. Maybe you don't have the port available locally because something else is using it, so you map it to the port you eventually want it to be on. These are variables that are exported from the env file just to keep things in lockstep. And you can actually set environment variables, like example. So if you now log into this in Docker login, I think it should work. Yes, you can now echo this. So you can actually configure a lot of what you're using in the Docker compose file, which is pretty cool. All right. Run as Docker container. That has been explained. You have the build and run. No changes there. I did just add the SSL file check to the regular run script before I built it directly into it. Docker compose. We've gone through Docker compose. The info.md, again, just updating my documentation. So I noticed that I had included something that wasn't actually needed anymore. It was done by default. So I don't need that anymore. And that should be the entire code review. I guess the only other thing I can show you is how we do the Docker login. So like I said, Docker is its own operating system. This is an executable that you can use, and this is just a way to easily get in and see what's going on. It's not really that useful for Spring, but certainly when you have a database container running and you need to actually access the database, add values, update values, you can do that here, and that's really nice. Other than that, that should be it. We now have gone from our first health check GET request on Spring to running it securely with a self-signed certificate to now being able to run it on Docker. Next step, we will create our front end. Can't wait to get started with that. Have a good one.